Hey guys, how we doing? We are ready to move on to the next section. This is section 5.4, and it is titled Use Medians and Altitudes. And so obviously we're going to have to define those two terms, and we'll have a few others actually in this section, but we certainly need to define those two. And so again, section 5.4, use medians and altitudes. So the first term we need to define is a median. And a median is just a segment, just a line segment. It's drawn from a vertex in a triangle. So again, the vertex is one of the corners of the triangle to the midpoint of the opposite side. Okay, and so that midpoint would look something like this diagram, to where let's take the blue line for example, to where we're taking it from vertex A to the midpoint of that opposite side, and so that's the median. And again, just like a lot of the other pieces that we've already talked about, there will be three medians in every triangle. So just like a triangle has three sides, three angles, it also has three medians. And so you need to get familiar with what that median is. So from a vertex to the midpoint of the opposite side. And then here's our third and final concurrent point that we've been talking about. So we had the circumcenter, remember? The incenter, and now we have the centroid. And those are our three different points that you need to keep straight from each other, and what kind of segments intersect each other to create that particular point. So this one's called the centroid, and so if you take all three medians of a triangle, they are concurrent, which again means that all three of them meet in one point, and that point for medians is called the centroid. Okay, so a little different term than the other two, but it's called the centroid. So here's two definitions that you need to know for this section here.
All right, guys, so when we talk about concurrency of medians of a triangle, we want to kind of wrap our heads around this idea that there's a 2/3 ratio from the vertex to the centroid. Now, when I think of centroid, I don't know about you, Mr. Scritchfield, but to me, centroid is the easiest one because I don't have to worry about perpendiculars and things like that, or bisectors, all that stuff. So really, what you just got to remember, guys, is on the centroid, what centroid really does here. Oops, let me swing this around here. What centroid really does is it allows us to say, all right, this piece is congruent to this piece here is congruent to this piece here, and this piece here is congruent to this piece here. That's what you really got to remember about centroid, is it's cutting those segments in half and then shooting from that middle point all the way over to a vertex here, or a vertex over here, or a vertex over here, and then this point right here is the one we focus in on, called the centroid. So it's really a pretty easy idea. Now,
It is.
where it's harder than the other three is in the math.
Yeah.
Because now you got to do some math with this one, and so that's where the challenge really comes into play with this, is the fact that you're going to have to do some math, and you guys see this fraction right here, and some of you guys, you see that 2/3 and you're like, uh-oh, not a fraction. I don't like fractions, Mr. Padella, Mr. Scritchfield. What am I going to do? Don't freak out, okay? So let's look at this a little bit more here, but just remember, we're going to have that 2/3 ratio, okay, from the vertex to the centroid. So here's a kind of another representation. So there's the longer piece, so that's going to be 2/3, okay, of S to A. And then that bottom piece from O to A is 1/3. So the whole piece is from S to A, and then the top piece is 2/3 of the entire segment, and the bottom piece is the other third. Okay, so fade that out there. All right, so if that's 8, all right, and remember that from SA to OA, that's 2/3 of the distance. Okay. And so if that's 2/3 of the distance, then 1/3 of that would be 4. Okay? And so basically, guys, you should be making some connections here that, if this piece was 8 at the top and that other piece was 4 at the bottom, Mr. Scritchfield, what kind of connection are you making when you see that it's 8 for the big one and 4 for the smaller one?
Looks to me like one of them's double the other one.
Yeah. I mean, the longer piece is always double the shorter piece. So even though it's 2/3 and this 1/3 stuff, just remember, the longer piece is double the length of the shorter piece. And so, let me just move this.
You just need to realize that the 2/3 fraction is double the 1/3 fraction. So that one piece is double the shorter piece.
So if that's 3, there's your shorter piece. Just double that and you get the longer piece. So you should be thinking 6. All right. So I mean, even though it's just 2/3 to 1/3 ratio, just remember it's really double the shorter distance or half the longer distance. Okay. And so the whole distance here, and they don't really talk about this, this is where the thirds really come in. The whole distance would then be, this whole distance would then be 9, and this whole distance here, whoops, this whole distance here would be 12. Okay, and so that's where that 2/3 plus the 1/3 comes to equal 12. And the 1/3, which is 3, and the 2/3, which is 6, comes to equal 9. And you can see how that part makes more sense about thirds. Okay, so let's go a little bit further here and really kind of have some fun with that last part about that third. So let's say now that we want to look at OU, OC, and CU. Okay, so they're giving us the fact that CU is 10.5. So if I come over here and I'm just gonna, I like to lay things out. So from here all the way over to here, they're now telling me that that distance is 10.5. Okay, so remember, that is the 2/3 piece and the 1/3 piece put together. So if we want to break that down into thirds, so that way we can figure out our two pieces, what are we going to have to do here? So now you just got to think. It's broken into 2/3 and a third. So if I take 10.5 and I divide that by 3, that's going to give me my 1/3. That's going to give me my shortest piece. So 3 goes into 10 3 times, leaves, and that's 9. And then I'm left with 1.5. So that is 0.5. So my smaller piece, which is OU, is 3.5. And if I double that, guys, that's going to be 7 for OC. And if you add those two together, 3.5 and 7, whoopsie. Wow, let me erase that. Sometimes this thing just don't like me. So 3.5 and 7, if you add those together, you get that 10.5. Okay? Anything, Mr. Scritchfield, you'd like to add there?
No, I think you got it.
All right. So let's just move this thing forward. So they give you that 7 straight away, and then the 3.5 for OU, which we figured out by dividing 10.5 by 3. All right. Now, the next thing you're going to want to do is you're going to want to find the midpoints of US and ST to locate the coordinates of the centroid. All right, so this is takes a little bit more math, but the math that goes into it really isn't all that hard. Now, I know that on the previous slide we were showing all 3 centroids, but if you think about it, you really only need, or all 3 centroids, excuse me, all 3 medians. You really only need 2 medians to figure out where the centroid's at, because where 2 cross, all 3 are going to cross. That's just the nature of the medians. So if you can find 2 medians, you can find the centroid. All right, and so what we're going to have to do here is we're going to have to find the midpoints of US. So we got to find out where that point is here in the middle of US, and we've got to find out where that point is here in the middle of ST, and then cross those lines and see what our centroid is, come up with an ordered pair. So Mr. Scritchfield, what would you do to figure out the midpoint here?
Well, before we do that, I just want to caution you guys on looking at the graph here, because it's a little different. Do notice that the boxes are 2 units, not 1 unit. And so when we're moving over to S being at 5, 5, notice that we're really only 2.5 boxes over and 2.5 boxes up. And so just be careful of that scale. But this is nothing new, guys. If you're being asked to find the midpoint, we have a formula to find the midpoint, and it's handily called the midpoint formula. And remember, the midpoint formula is the average of the x's and the average of the y's.
Oops, kind of butchered that.
So we just need to distinguish between the 2 x's. So we typically call them x of 1 and x of 2. Take the average of those. How do you average 2 numbers? You add them up and divide by 2. So we want the average of the x's, average of the y's, and that makes up a point, an ordered pair. So there's our formula. We just need to plug into that.
So for the midpoint of, let me just erase that out here, and we'll just start out here with this. So the midpoint for US, let's go ahead and do that one right now. So if I find the midpoint of US, I'm just going to go -1 plus 5 divided by 2, comma, 1 plus 5 divided by 2. And so now, for the midpoint of US, I'm going to get -1 plus 5 is 4, divided by 2 gives me a 2. And then 1 plus 5 is 6, divided by 2 gives me a 3. And so I know that my midpoint will be over 2 and up 3, puts me right there. Okay? And now I got to do my midpoint of ST. So my midpoint for ST will be, 5 plus 11 is 12, divided by 2,
Wait.
comma.
5 plus 11, 16.
Oh, my bad.
Yep.
Math teacher. Yay.
Good thing
All right.
we're both here to catch each other.
That's right, see? Whew. Check that work. 5 plus 11 is 16. There we go. Then divided by 2. And then 5 minus 3 would be 2 divided by 2. So I reduce that down, and that gives me an ordered pair of 8, comma, 1, which 2, 4, 6, 8 up 1 puts me right there. Okay? Now, in the sheer nature of I can't draw a straight line, we're going to switch back over to the PowerPoint, so all that stuff just went away. And now we're going to go, okay, 2, 3 there, that was the first midpoint we found. 8, 1 there, that was the second midpoint we found. And now we're going to remember the median goes from the vertices to the midpoint on the opposite side. So that first line is going to go, well, your two lines are going to go from U over to 8, 1 and from T over to 2, 3. And now you can see that our centroid is right over here. It meets right there. And so our centroid is over 2, 4, 5 and up 1. So we get a centroid of 5, 1.
5, 1.
Okay?
Okay.
Oops, let me go back here in case you want to look at that for a second longer. All right.
All right. Last slide for today. Last term is talking about altitude. And the altitude you can pretty much compare to height of a triangle. Altitude is the perpendicular segment, and the key part of that is perpendicular. It has to be the perpendicular segment from the vertex to the opposite side, or the line that, or to the line that contains it, in case it doesn't actually reach that side. And once again, every triangle has 3 altitudes depending on what vertex you're taking it from. And so if we take the first triangle here and take the altitude of the top vertex up there and take it perpendicular to the base, then that orange line is the altitude of that triangle. The second one, basically the same thing. Those two are perpendicular. Now the third triangle is a little bit different, and you got to see where that perpendicular height comes in, because it's not going to reach the opposite side inside the triangle, and that's okay. There's no rule that says the altitude has to be inside the triangle. This one happens to be outside the triangle. And so notice that we're dropping a perpendicular to the opposite side, and we have to extend that opposite side, the base of the triangle, to go outside the triangle in order to match up with that. That does not make the base of the triangle longer. It just allows us to draw the vertex to it. You also have to be careful on this triangle to make sure that that third side is not going to be the altitude, because it's not perpendicular to any of the sides. And so don't make that simple mistake there. Altitude always has to be perpendicular. Absolute key there. Right, Mr. Biddell?
That's right.
Okay.
I mean, guys, if you ever want to find the height, you've got to be able to make a perpendicular somewhere. And whether it's inside the triangle or outside the triangle, you've got to connect it through a perpendicular. No perpendicular, no altitude.
Okay, guys. We'll see you in class.
What the heck? Who are you talking about?
Can you fill out your name?
Our kids in China that we're teaching.
Very nice.
It's all the side money that we're making on teaching other students. It's where we make our real money.
That would be smart.
We hit stop ready?
Yeah. Our pause.
Can I go to Weiss?
No.